Okay, this lesson is going to be, as it says, quadratic inequalities. So, example 1. Use a graph of y equals x squared to solve the inequality x squared greater or equal to 1. So that's the graph of y equals x squared. And if x squared is greater or equal to 1, but we're also saying that y equals x squared, which it is on this graph here, then if y equals x squared and x squared is greater or equal to 1, putting the two together, that must mean that y is greater or equal to 1, because in this inequality here, we're simply replacing x squared with y to give us y greater or equal to 1. And the line y greater or equal to 1 is a horizontal line, so we want the part of the curve which is above that line. The line y equals 1 cuts the curve where x is 1 and x is negative 1, so these two values here. That's the bit of the curve that we want, the highlighted bit, and therefore those two green regions are the x values that we want where the curve lies above the line y equals 1. So the x values we want to the right are x greater or equal to 1, and then to the left, x is less than or equal to negative 1. So those are the x values that satisfy the inequality x squared greater or equal to 1. The strictness of the inequality in our original question, the strictness means this said greater or equals to, is matched by the or equals to in our answer. In example 2, this time the inequality we're solving is x squared greater or equal to 4. Once again, that's the x squared curve, and if we want x squared greater or equal to 4 and y equals x squared, that's the same thing as saying where is y greater or equal to 4. So we want the part of the curve which is above the line y equals 4, so we'll mark y equals 4 on our graph. There it is. We want the bit of the curve above that because we want to solve y greater or equal to 4. And the x values where the line y equals 4 meets the curve are 2 and negative 2. And the yellow bit is the bit of the curve we want. So that's those two green regions for our x values. To the right, that's x greater or equal to 2. And to the left, x greater or equal to negative 2. And those are our x values that solve the inequality x squared greater or equal to 4. And once again, the strictness, i.e. the or equals to in the question, is matched by the or equals to in the answer. Example number 3, it's a less than this time, and it's a strict inequality. So x squared less than 9. If y equals x squared, which it is on our curve, we want the bit of the curve where y is less than 9. So it's the bit of the curve below the line y equals 9. So y equals 9 is that horizontal line as drawn on the diagram. That meets the curve y equals x squared at the point where x is 3 or x is negative 3. The bit of the curve we want is below the line, so that yellow bit there, and therefore the x values that give us that yellow bit of the curve are between 3 and negative 3. So our solution, where is x squared less than 9? X squared is less than 9 as long as x is greater than negative 3 but less than 3. And one final detail, the original inequality given to us was strict, i.e. it doesn't allow for or equals to, so neither does our answer. There's no or equals to in our answer.